Stoich 6, limiting and excess reactants. Practice problem 1. Iron metal reacts with oxygen gas to form iron 3 oxide. 0.25 moles of iron reacts with 0.5 moles of oxygen gas. Determine the limiting reactant, the theoretical yield in moles, not in mass, not in grams, of iron 3 oxide, and the amount in moles of excess reactant remaining. First we'll balance the equation. So what do we need to do? We're going to convert the moles of reactant to moles of product. And we'd use a molar ratio to convert that. The reactant with the smallest mole coefficient ratio is the limiting reactant. So let's find out which one of these has the smallest mole coefficient. Do that by mole divided by the coefficient. So we've got the moles of the iron here, and we're divided by the moles of the coefficient. Let's stop a second and see which part of the Stoich roadmap we're going to use. Just a simple bit, it's just moles to moles, doesn't want anything converted to mass. So let's get back to this limiting reactant. Moles of the reactant divided by the coefficient of the reactant. Iron is 0.25 moles and has a coefficient of 4. 0.25 divided by 4 is 0.0625. And do the same for the oxygen. We've got 0.5 moles of oxygen divided by the coefficient in the balanced equation. Gives us 0.17. So obviously the iron has the lower ratio, so iron is the limiting reactant. So now we'll start putting things into our BCA table. We've got 0.25 moles of iron to begin with here, and all of it will react. Iron is limiting, so all of it will react. Therefore, the change in moles during the reaction will be 0.25 moles. And so we're going to get no iron remaining at the end of the reaction. To find the amount of oxygen reacted, we'll use the mole ratio from the equation. We know that we've got 0.25 moles of iron because it's the limiting reactant. And for every 4 moles of iron that reacts, 3 moles of oxygen react. So for every 4 of these, 3 of these react. The conversion ratio, conversion factor, be 3 moles of oxygen over 4 moles of iron. Oxygen will go on top because that's what we're trying to find. If you are ever unsure about the way the ratio should go, just remember that what you're trying to find goes on top. Okay, let's stick these in. We've got 3 over 4, cancel the units, and gives us 0.19 moles. That is what the change of oxygen will be during the reaction. Start with 0.5, we'll take away 0.19 moles because that's how much react. We'll end up with 0.31 moles at the end of the reaction remaining. So 0.31 moles of oxygen is in excess at the end of the reaction. To find the yield in moles of the iron oxide, we use a mole ratio from the balanced equation. We'll know that 0.25 moles of iron reacts as it is the limiting reactant, and we can see that for every 4 moles of iron that reacts, we get 2 moles of iron oxide. The conversion ratio is 2 over 4, and remember that what you are trying to find always goes on top. We need to find the moles of iron oxide. Stick it in there, cancel out the units, we get 0.13 moles of iron oxide. And I've written it wrong here for some reason. I'm not sure why I've written it wrong. And I wrote it wrong up there as well. Oh well. Should I correct it? Might as well just correct it now. 2, 3, 2, 3. No, it just stayed the same. Never mind. Okay, so there's no product at the beginning of the reaction, so let's put 0 in there. And since 0.13 moles were made, we have 0.13 moles at the end. And so we have no iron remaining at the end. So iron is definitely the limiting reactant. It's all used up. Got 0.31 moles of oxygen left unreacted. So the yield of iron oxide will also be 0.13 moles. That's how much was produced. and the moles of excess reaction remaining will be 0.31 moles. Let's check significant figures. We've got 2 at the beginning of here, and so we need to put 2 significant figures in our answers. Okay, splendid.